Hello there, welcome to the learning of engineering tutorials. In this video lecture, we are trying to learn what is the thin cylinders, right? And what type of stresses are going to be generating on that. Before going to that, we know the thin cylinders are widely using to store the fluid under certain pressure conditions. At the same time, the design of that pressure vessels to withstand that the pressure is going to be the utmost important. And first we need to understand what type of forces are going to be coming to the system and how the stresses are going to be developing and at the different conditions. So there we can see here, for our mathematical convenience purpose, we are taking, suppose we can take a oil containers or a milk vans, suppose they have the pressure vessels are there, right? So then for the mathematical convenience here, I took it here, it is going to be the cylinder cross section. There we can see, we are assuming that inside the cylinder there is a fluid is there. At the same time, it is exerting the pressures on the walls. So that I am going to be saying, this is going to be your longitudinal axis and this is going to be your transverse axis. So when the pressure is going to be acting, so then what happened? This is trying to move in this direction because the pressure is going to be acting in the transverse, that is the circumferential directions. So then automatically the member is going to be trying to move in this direction. And similarly, the longitudinal direction pressure is acting in this direction. So that means it's trying to move in this direction. So we know that. So that the same here we have taken in the cross section, that is in the circumferential direction. There we can see the pressure is going to be acting and the fluid pressure is going to be acting inner wall of the cylinder. So then this is the cross section. Then what happened? This material is going to be subjected to the certain type of the stresses and the strains. And automatically, and it is clear that when the working stresses are more than the permissible stresses of the system, then automatically the failure is going to occur, that is going to be burst the system. So then what will happen here? So when I am going to be taking in the longitudinal line, that means when the circumferential pressure is going to be only I am going to be considering here. So then what I am going to do? So this member is going to be subjected to the circumferential pressure. That means in the circumferential direction, the pressure is going to be acting. So then what will happen? The material is going to be start to fail in this direction. So that I have shown here that figure here. Can you see when the pressure is going to be acting in this direction? So can you see? So then automatically this is going to be the upward direction, the pressure is going to be acting. So then it will going to be separate the material in the longitudinal direction. But when it comes to here, so already we told the permissible stresses and the working stresses. So when the working stresses is more than the permissible stresses, that means the resistance of the material is not offering, then automatically it will burst. So that the cross section is going to be happen like this. So can you see the internal pressures is going to be acting and the material internal resistance forces or the stresses are going to be acting in the opposite direction. So then this is the sigma we have taken. And similarly, the diameter of the cylinder, so this is going to be your diameter of the cylinder. That means the inside, the pressure is going to be acting, that is the D. And it has the thickness is the T is going to be, we do have. So then the total length of I am considering L is going to be the length of the cylinder. So now we need to find out what is the hoop stresses in this system. Hoop stress, or we can say circumferential stress. Thus I am going to be designating with the sigma 1. So by using the sigma 1, we need to determine it here. So what are the forces are coming and what type of forces are developing inside the material, and then we are going to be equating these two. So here we need to find out the hoop stresses. Then how could you find out the hoop stresses? So I am going to be taking the projection of this object. So when I am going to be taking the projection means here, the top view I am going to be getting. So that I am going to be drawing over here. So this is going to be representing in this direction. It's like a rectangle box. So right, and this is going to be your thickness of the material that existed on the both sides of the diameter, right? So this is going to be the thickness we do have, and here also another thickness, and this is going to be representing your diameter of the pressure vessel. Now in this case what happened, the pressure is going to be acting over here and the stresses are going to be developing inside this material, right? So here the two types of pressures are going to be, one is going to be the pressure due to the fluid is going to be developing. The second one, the stresses are going to be developing inside the material, because whatever the pressure is coming in the forces and then the material is going to be absorbing. So then how could you write over here? So there we can see, so this is going to be your pressure is going to be. Can you tell me how the pressure is going to be acting over here? This is going to be your length of the cylinder, or we can say the small l or capital L, whatever it may be. So then now can you tell me what is the pressure over here? The fluid pressure P is equal to, so that is equal to the normal force acting by area we have to be taken. So this Fn is going to be nothing but your normal force, that I am writing the force is equal to P into area. Now can you tell me the pressure area, that means the pressure acting area. Can you see this is the area it is going to be acting, that is the D into over a length L it is going to be, that's going to be D into L is going to be your the fluid pressure. Suppose this is going to be the fluid pressure force we are taking. And similarly, the sigma 1, I am going to say these are the stresses are going to be developing inside the material, that is the thickness of the T and over a length of L. So the sigma 1 is equal to the force which is developing, the forces are going to be coming because of the fluid pressures. So that the fluid pressure is equal to that area we are going to be considering. So from this one, Fp is equal to the sigma 1 into area is equal to which area we need to be considered. Can you see this is the thickness and this is the L. This is the area is suffering with the stresses. So that I am going to be taking T into L, and this side also we do have. So that means 2 into T into L is going to be your area, right? So then Fp is equal to 2 into sigma 1 TL, we got it. So we know this is the stress is because of the working stresses, that means the pressure is going to be, this is the working pressure is going to be acting on the material. And similarly, this is going to be the Fp is going to be the pressure, this is the force is going to be developing inside the material. So then what happened in the limiting case, these two forces are going to be equal. I am going to be considering here. That's going to be, this is the equation 1 and this is the equation 2. So then what happened, 1 is equal to the 2, that means applied force is equal to the developed force inside the material. So that's going to be P into dl, we got it. That's going to be 2 into sigma 1 TL, we get it. So LL will going to be cancelled over here. Sigma 1 is equal to PD by 2T, we got it. So can you see here that is the value is equal to, so the total, the stresses are going to be developing inside the material, that's going to be P D by 2T. So there we can see, so in this case what will happen, P and D is in the numerator and T is in the denominator. Now we will see some mathematical analysis over here. When the pressure is going to be increases inside the material, and then stresses also going to be developing inside the material. So that means pressure increases, resistance force going to be increases. At one point of the time, the resistance force is going to be less than your applied force. Then automatically failure occur. When the diameter increases, then directly proportional to the circumferential stress or the hoop stress. And then when the thickness is going to be increases, this is inversely proportional to your circumferential stress. Then the sigma 1 is going to be start to reducing. So this is the way we are going to be calculating the circumferential stress or the hoop stress of the thin cylindrical vessels when it is subjected to the internal pressures. And the design also will go over like this. So still, if you feel any difficulty or confusion in understanding of this subject or this topic, and please put in the comment section so that I can give the clarification over that. Thank you.